Hello everyone. So we have seen the first module and we have even completed the second module. Now it's the time to start the third module. So in the third module we are going to study structural design patterns. Okay, so we have seen three types of design patterns, means we have categorized the 23 design patterns into three categories, right? So that is a structural, creational and the behavioral. So these three types we have seen. So structural was, that is, it was focusing on how the classes and the objects were interacting, right? You can recall. So that was the thing we studied, right, in the second module. Even I have told the definition in the first module also. So structural design patterns, where it is going to focus on how to implement the classes and the object and how the classes and objects are connected to each other or composed. Okay, so in this particular, so separately we are going to see how the classes are designed, how the objects are designed with respect to the particular design pattern. So that is going to come across the structural design pattern. In the same way, we have seen the definition of the that is a creational design patterns and the behavioral design patterns. So creational design pattern, it is going to focus on how the class is implemented, means how the class is created. Okay, so how the object is created. So that thing we are going to focus, that is a creational design patterns. Whereas in this particular behavioral design pattern, we are going to see how the class is going to interact with the object, how the object is going to interact. So how, in which way they are going to communicate with each other, the behavior. So that concept we are going to see in the behavioral design patterns. So in this one, structural design pattern, so we are going to focus on how the classes and the objects are composed, the structure of the class and the object, how it is being implemented actually. So that thing we are going to see. So while studying here, so usually what happens, we are going to see the structure of this classes and object. Why? Because we need to make this class and object into a huge complex structure. So in order to make a huge complex system, what we are going to do, we are going to use the concept called inheritance, right? So what we are going to do here in the inheritance, so while using this inheritance, so we are going to incorporate the features that is present in the parent class. So from a parent class, we are going to derive few of the features, or you can have your own designs also. So if you derive the features from the parent class, even you can override that one. So means adding the functionalities, right? So adding the functionality, you are doing this in this one inheritance, and it is mainly for which concept, that is a reuse concept. Already the code is existing, so you are going to reuse that one. So that is what the meaning of that inheritance we were focusing. So here, in order to maintain the complex structure between the class and the object, classes and the class with the other class, object with the other object. So in order to maintain these kinds of relationship, okay, so we are going to have a structured one, the complex structure. So for that, the very first we are going to use the inheritance, that is a reuse concept. In this inheritance, even we can go for, that is a multiple inheritance. You have come across this one, multiple inheritance, where two or more classes will be using the same parent class, right? So for example, if we be having a class A, so that can be derived in the, so in numbers of classes. Okay, means the features can be derived from the parent class to any number of subclasses, right? So maintaining these kinds of structure will give me the complex structures in the class and the objects. Okay, so here I am going to focus on the structural design patterns. So I need to study, so what are all the methods used in order to implement the object, in order to implement the classes. So those things we are going to see here. So in the structural design patterns, we are going to study 7 design patterns, that is in the third module. Okay, so that is in the first design patterns, we are going to see, that is a adapter design pattern. Okay, so we have we need to study adapter, abstract method, proxy, okay, bridge design pattern, facade design pattern, flyweight design pattern. So means we are going to study the 7 design pattern that comes under the structural design patterns. Okay, so that is, I'll write it up: adapter, bridge, composite, decorator, proxy, 2 more are there, flyweight and the facade. So, these 7 design patterns we are going to study in the syllabus. I already told you, so we have got 23 design patterns, but we are not focusing on all those 23 design patterns. We are focusing on structural design patterns. Okay, so we have categorized into 3 types. So, under that, in the syllabus, he has kept the structural design patterns for studying. So, under that we have got the 7 design patterns. The very first design pattern we are going to consider is adapter design pattern. Okay, so before that, so I have given a complete details how you need to go with the design pattern catalog, means the how to describe the design pattern. For each and every design pattern you need to follow the description, means one by one, which is the first part we need to explain, second part, third part, and so on. We were displayed with the so many operations in each and every design patterns, right? So we'll follow that procedure and we'll study each and every design patterns in detail. Okay, so before that you should know what is a structural design pattern, how it is being used. Okay, so how it is going to be created. So structural design pattern, it mainly focuses on how the structure of a classes and the objects are done, how they are usually composed. So we are going to use the inheritance, multiple inheritance concepts. Okay, so he is going to use that one and explaining the structural design patterns. Okay, so under that we'll see the adapter design pattern. Adapter design pattern, first design pattern that what we are going to study. So what is the definition of adapter design pattern? So that is, it is going to convert interface of a class into another interface that client expects. And allows classes work together which are incompatible. Okay, so here the very first thing we are going to see the adapter design pattern. So I need to follow the description of the design patterns. In the description we need to study what is the name of a design pattern, intent section, also known as structure, participants, collaboration. So these things we studied right in the first module, so in a syntax level. So now we need to follow that one in order to study all the design patterns. So under that I have written adapter design pattern, the definition of the adapter design pattern. So this design pattern, it is going to convert the class interface to the client requested interface. Means I am going to design according to my logic based on the requirements I have gathered, and then the client may request in a different way. He may expect the changes in the interface design. So if you want to do changes for the client request and you have got some issues there, some problems there, so you can use this adapter design pattern. Even it helps helps you to allow the classes work together, which is not a compatible, means the some of the classes they are not going to work together. There may be some issues with the interfaces or the object composition, or maybe the any of the kind the classes are not compatible with each other. In such situation also you can use the adapter design pattern. So that there are two cases where you are going to use this design pattern, that is converting the interfaces from one class to another of the form that is requested by the client, and also the classes which is not compatible with each other can be worked together. So that is how the adapter design pattern is going to work. So we will see the that is also noun name. Also known as, okay. So that is wrapper. So wrapper is the another name for the design pattern adapter. So that is in this one. So this will become your intent section, okay, and next is your also known as, okay. So this is the intent, also known as. So very first one, adapter is the name of a design pattern, and the intent, the intention of the design pattern is that is converting the interface to a client requested interface. And then also known as, the other name for the design pattern is wrapper design pattern. You may get the question like this, in detail explain the wrapper design pattern like that. So don't get a confusion there. So that is adapter and the wrapper one and the same. So you need to remember this one, okay. So next we'll see the motivation. Motivation to study or to use this design pattern, okay. So why I need to use this adapter design pattern? What is the motivation behind this one? So in this one, what he has explained here, so when you want to use this adapter design pattern in a situation where the client is requesting some format, for example, I'll write with the diagram. That is a motivation. You have got a diagram. With the diagram, I will explain why I am going to use this adapter design pattern, okay. So those are the subclasses. So you can just see this diagram. I have taken this diagram to explain what is the motivation behind using the adaptive design pattern. Okay. So here he has taken an example of a drawing editor. Drawing editor means editor where you are going to draw objects, shapes. Okay, so if you are going to design some drawing contents, so what you are going to use? You are going to use lines, object of different shapes like circles, rectangle, boxes. Okay, so you are going to use different geometrical objects. So you are going to use the different geometrical objects there when you are going to use the editor, that is a drawing editor. So when you use this drawing editor, so you may require the class, okay, so that is a shape class. Okay, so shape class where it contains the different shapes that you can use in the drawing, that is a line, okay, circle, rectangle, square, triangle, the different shapes that you can use while designing or while drawing, right. So here in this shape class, okay, so it is not going to give you any implementation details there. It is just going to give the means abstract, just a prototype definition. You can tell this as a abstract class. Okay, but doesn't include any implementation details within it. Okay, so within this shape class, okay, so which includes all the different kinds of shapes you can use in the drawing editor. So I told you so many examples, so many different shapes you can use. So what happens when you use the text shape? Okay, so normal drawing with the figures with a geometrical object, that is different, but when you incorporate the shape of a text, that leads to a complexity. Why? Because texting the type means characters itself a huge task, means it requires a buffering, so it requires a manipulation for each and every characters that you are going to enter. So you can just imagine if I provide the shapes for each and every characters when you are going to enter to a keyboard, so it requires a complex structure there. So because for each time I need to maintain a buffering in order to go with the shape of a text. Okay, so a shape of a different geometrical object is different, so that I can easily go with it. But if you want to design or incorporate the text shape also, it requires some huge complex time. So in order to overcome this complexity, so why? Because the shapes class, it is going to include the lines, even it can include the circle. Okay, so it may include the same operation that is present in the parent class, and it even can include its own design there within this operation section. So it may even go with the many of the different shapes that is available. But when you want to incorporate the text shape, so usually what happens, a text shape will be incorporated in the interface design itself. So complex toolkits will be there, no? So in the library section, so you will be having the predefined library and the toolkits already there, that is a framework. So within a framework, in order to change the text and the shape of a text, there will be a complex structure already available in almost all of the platforms. So when you have the different text shape, okay, that is a class that is maintained as a external editor, that is a interface toolkit editor. So it is already in a separate class, and you have got another shape class, okay, in a drawing editor. So I need to incorporate, I need to combine this shape class and the text shape class together. Okay, so why? Because so if you go with the only geometrical object usage in the drawing editor, that's easy for me. I can directly go and write the program in such a way that I can drag and drop the things. But whereas when you are going to apply the same thing for the text, it requires some manipulations, buffering and everything. And usually we are not going to design a shape of a geometrical object keeping in mind that in future I am going to use this shape of a text also. This will come in a different part and this will come in a different part. So two different classes. So in the text shape, what happens? So it will be in a interface itself, in a toolkit itself, it is going to be incorporated. It will be present there itself. I can directly drag and drop from there. I can even change the shape of a text, size of a text from there itself, from the toolkits. So now what I need to do, I need to bring that text to shape class to present this shape class. Okay. So how I am going to do this one? So for each and every object that is created, that is for drawing editor. So this you consider as a graphic objects. Okay. Means graphic objects are nothing but the shapes you are going to use while drawing. Okay. So for each and every graphic object you are going to use, okay, it is going to create a separate classes, that is a drawing editor. And I told you this is a shape class, which is a abstract class. Under that you have got two classes here, that is a line and the text shape. So I'll tell about this text shape. Before that we'll see this one. So circle, line, even I can incorporate the rectangle, square and so on. I can write for this that is a shape abstract class as a derived classes for this. So why? Because I can inherit the features that is present already here, and even I can go with a different coding for the line, different coding for the circle, different coding for the rectangle and so on. So if you want to incorporate this text shape into the design part in order to do the combination of these two classes, that is a shape class and the text shape class. So you need to have a, that is a adaptive design pattern. Okay. So here this text to shape, it serves as your adapter. So this means it is a complex topic. Why? Because so easily I cannot incorporate, or easily I cannot change or merge the shape class into a text shape, because text shape it is of different class which will be in a toolkit itself, and this shape is it is of a class with respect to the drawing editor. I need to merge these two classes together, and I need to design the interface that is requested by the client. Means a client is requesting me in order to include the text shape as well as the geometrical shapes in a same class. Okay. So that is why I am going to use this adaptive design pattern. Here the text shape serves as a adaptive design pattern. Okay. So this is means I am going to bring this class text shape here. So I am going to use some of the features that is present in the toolkits there, and even I am going to use the information that is present in the abstract class also. And then you can see, so using this one, it's easy for me to now go with the another class, that is a text view. So using that text view class, I can directly go with the manipulation of the that is a editor. So means drawing editor. So I can just go on drawing, and even I can go on with the labeling part. So why we need text is just to label the parts in a diagram, right? So that is why. So it is easy for me if I include the adaptive design pattern, because this class was not actually present in the shape class. Okay. So why? Because this was incorporated in the toolkits itself as an interface for the users. So now what I did, I just took up the information that is present in the text shape, and I merged the contents to this shape class. Okay. And then I have got another class, that is a text view. So this I am going to tell it as a client requested format. This is a client requested format. This is a client request format. Actually, I have designed using a drawing editor. I just use the shape, okay, and within that I use the bounding box and create manipulators. A few operations I used, and keeping this as abstract class, I have got some derived classes. Don't think of this right now. So a line, circle, rectangle, like this I designed initially, but when the client requested in order to merge the shape of text with this shape itself, okay, shape of geometrical figures and the text, both are to be merged together. So in such situation, I use the adaptive design pattern. So that gives the interface, okay. So it is an interface, actually I can tell. So this using this interface, so we have got that is a text view class. So that implements that get means it is going to use the get extend method. So it is going to work accordingly when you are going to type a characters. So within this text shape you have got the, that is the output here, so means it is going to use the object and it is going to return next, that is a get next in operation, and then it is also going to use some of the manipulators if you are going to provide shapes into it, the size to the text or so on. So if you provide, so it is going to manipulate those, that also, so that is the respective operations it is going to return. So in this particular example what I have taken, so this drawing editor, okay, so this is a drawing editor, and then this one is a, it is a platform, so it is a area where I am going to apply the adapter design pattern. So from this drawing editor I actually wanted to design the shape class which is going to have a derived classes with a different that is a graphical object, a line, the rectangle, square and so on. And just what I thought of is, so if I do the merging of the text shape within this one, so it will be a good task, so that the client is going to be accepted in the same way. So in such a way what I use adapter design pattern. So it merged the text shape class within this particular shape of objects, and then it provided an interface. Within that interface you have got a client requested format. So the client was requesting the same way, that is he just wanted a shapes as well as the text view, okay. So the same, the both cases were attained in this particular example. So that is the motivation behind this using of this particular design pattern adapter, okay. So adapter design pattern, so will convert the interface that is created by you, the class interface created by you, into the client requested interface. So it is going to convert, okay, and then it is also going to merge, or it is going to give the combination between the two classes which is not compatible. So here the shape and the text shape was not compatible, because this text shape was in another toolkit and this shape was in another toolkit. So we merged these two together. So that is how the adapter design pattern helped me to find out the solution that arise, okay. So that is the motivation behind the adapter design pattern. Now we will see that is applications of this design pattern. Where are all the applications can be found out. Applications of design pattern adapter. Now we have seen the motivation behind this adapter design pattern. Next we are going to see applications of this adapter design pattern. So we are going to use this design pattern where you want to use an existing class and its interface does not match with the requirement. Means you are going to use this design pattern. So when you have got already existing class and that class is not meeting your expectation, your expected interface. So in that case you can use this adapter design pattern. That is the first application. So you have got already existing class and that class interface is not in the format that is expected by you. And we will see the next application. You want to create a reusable class that cooperates with unrelated or unseen. So that is, so I explain in a motivation itself, that is when you don't have the classes of the same kind, which is of completely different background. So that is we used text shape that is available in the toolkit itself, and the shape abstract class that is within a graphic editor. So we combine both together, right? So in order to do like that, so you can use this design pattern. That is, if you want to create a reusable class that cooperates, okay, so that cooperates with the unrelated or unseen unfutured seen classes, okay. So if you have the reusable applications, so if you want to use the other classes in further, so the existing classes can be used further, so that is a reuse concept. In that concept, if you have a classes that cannot be mingled together, that is not relevant with each other, so those concepts can be merged together using the adapter design pattern. So we'll see the next application. You need to use several subclasses. That is, when you want to use the several of the subclasses, I told you, no, so that is in that is a graphic editor. So within a shape class, so we had got so many objects, that is the graphic objects, so that is a subclasses, line, circle, square, rectangle. There were so many shapes available, dotted lines, stretchable lines, arrow line. So we have got so many different kinds of shapes available. So when you have got so much of subclasses, so in that situation also you can use the adapter design pattern. So totally we have got the 3 applications that is mainly focused. So very first one, so when you want to change the interface of your wish to a means the client request format. My wish means that is the developer who is going to design the interface based on the requirements, and further that can be redesigned based on the client requested format. The means where the client is going to request in another format. So in that situation you can use this one. So where you can change the interface of the existing class to another format. And in the second one, so that is so you are going to have the reusable concept. So and that classes are not going to be related ones. So in that case also you can use this one. And when you have the more number of subclasses, in that situation also you can use this particular adapter design pattern. Now we'll see the structure of this design pattern. The structure of the design pattern. First diagram what I explained is a diagram to explain the motivation behind this adapter design pattern. Now actually I am going to tell the structure of this design pattern, the syntax of the design pattern, how we need to use it. So through a diagram I am going to write. So this is the syntax, you can tell. So in order to use the adapter design pattern, so client, I'll just give a resemblance here. So client you can imagine with respect to the drawing editor. We studied in motivation, no? So that I am explaining. Drawing editor, you can take it as a client. Okay, and the target is nothing but where we want to apply the adapter design pattern, that is a shape. Okay, shape was our target, and the adapter is the class where I told you. So that is a text shape. Text shape was our adapter, and adaptee is what? That is text view. This class we have seen, no? So you can just recall the previous diagram I explained in the motivation. So in the motivation, I have taken this words, that is a drawing editor, shape, text shape, and the text view. So I will see with syntax now. So you can recall very fast now. So you have got a client, you should have a client in order to use the adapter design pattern. It is a syntax diagram. So you have a client, so the client is having the a class, that is a target class, where he is going to design the expected requirements or what he is collected from users. He is going to design that one, that is a target environment where the adapter design pattern may take up. Okay, so here, so we have got a adapter. Adapter is a design pattern, so which is going to give us a solution in order to incorporate the requested interface changes, and even the that is combining of the unrelated classes with each other, that is the shape class and the text shape class, both were combined with each other to give rise to the, that is a client requested format. Client requested format was the, that is a text view. So that is known as the adaptee here. So the syntax name, the particular name for this one is a adaptee, and the class where I am going to use the adapter is known as the adapter for this that one. So there I use the text shape as a name. I cannot use the adapter there, so I can just tell text shape is a adapter design pattern. Okay, so for adaptee I use the text view. And then the respectively the specific request can be generated here. So based on the instance creations and the instance object creations. So here, so this structure will tell that is we should have a client. We should have a client that is a target environment. We should have a adapter, and that adapter, it is going to design the format that is requested by the client. So this is the few of the section you need to concentrate. So that is a major, we have got a 4 parts, so that you can remember. So that is a structure of the, that is adapter design pattern. So now we will see the participants. So participants are nothing but the, so these things. So participants are nothing but what I have taken here, no. So this I am going to call it as a participants. So another section, that is participants. So participants are nothing but the major part I have used, that is a client I have used. Okay, so then I have used a target, the elements that you can use in the structure. So those are all becomes your participants, adapter, and then the adaptee. So these are the 4 participants you can expect in the adapter design pattern. So by looking at the structure itself, you can tell so what are all the participants involved. So for this also you need to write the description, that is a client is a person who is going to request the operation. So that is the graphic editor was the client in an example. So that is you can remember, and the target is a shape class, so where we used as an abstract class. So it was having the definition. So under that we had a subclasses. So those subclasses were deriving the features that is present in the shape classes, right? So that was our target. And then the adapter. So adapter we used in order to do some changes in the interface and even to combine the unrelated classes. So that is the adapter, and the adaptee is the one who has been changed by usage of this adapter design pattern. By making use of this adapter design design pattern, we have got a adaptee, means we have changed the request to a particular format that is requested by the client. So these are all the participants. Okay, so next we will see the next section in this one. So that is collaborations. So in the collaborations, the client is going to call the requirements based on the adapter instances. Means we are going to create the instance for this adapter. So based on the instances, so this particular client is going to call up the activities, and the same way adapter instance is going to be connected with the adaptee. So it is going to call up the actions, means it is going to perform the activity. So based on the instance that is created here. So collaborations are nothing but how it is being collaborated with each other. So client is collaborated with the adapter is collaborated with the adaptee. So client is going to manipulate using the instance of the adapter, and the same will be done by the adapter to adaptee. So that is a collaborations. Next we will see the consequences that can arise. Next section is consequences. So we will see a few of the consequences that can arise. Adapts the adaptee to target by committing to a concrete adaptee class. Adapter overrides some of adaptee's behavior because it is a subclass. Introduces only one object So we have got a consequences, that is adapter adapts the adaptee to target by committing to a concrete class. Means we are going to use the adaptee. So that adaptee is the one who is a requested format, So here it is going to commit to a concrete classes. Means when you are going to use the adapter, it is going to adapt that particular adaptee. Means it is going to have a link interface between the that is adaptee, between this adapter and adaptee there will be a interface. So it is going to have a concrete class between those two. So that is what it is going to write here. So which makes the concrete class there. So that is the first consequence, and the second one is the adapter overrides some of the adaptee's behavior. So since the adaptee is a subclass of the adapter, it usually overrides the behavior. So means that is your adapter, it is going to sometimes the adapter is going to override the behavior that is present in the adaptee itself. Okay, so whereas this adaptee is a subclass of the adapter, and this adapter is going to override the features that is present or the behavior that is present in the adaptee itself. So that is another consequence, and it is going to include only one object. So for each and every classes we are going to create, so it is going to include only one object, in such a way that it doesn't require any other further pointers in direction. So that may be the advantage actually. So consequences are nothing but the advantages and the disadvantages, both we are going to discuss here. So might be this too may be the disadvantage, but this will be the advantages because it introduces only one object and it does not require any other pointer concept to go for the indirections. So that is another consequence, and the fourth consequence is a single adapter works with a many adaptees. So when you design an adapter, so that adapter it is going to work with many different adaptees. So not only one adaptee is telling, so is going to include many numbers. So there might be n numbers of adaptee. Single adapter, it is going to handle the many adaptees. So that is actually the advantage, and then it makes it harder to override the adaptee behavior. I told you here, it is going to change the behavior of the adaptee itself. The adapter class, it is going to change the behavior of the adaptee. So sometimes what happens while changing the behavior, so it is going to be the harder one, so which makes harder in order to do the overriding there. So that may be the disadvantage of the particular usage of the design pattern. So apart from this one, we have got few more drawbacks or consequences to consider. So we'll see those also. Few more issues to be considered apart from this consequences points. That is, you need to consider how much adapter may adapt. Okay, that is a question mark actually we need to discuss. So how many adaptee he can include? I told you it can have the more number of adaptees in a single adapter. So how much? So that is the another issue you need to consider while using this adapter design pattern. And the next is next is a pluggable adapter. Pluggable adapter is nothing but, so you are going to hide the assumptions, means you are not going to make the visibility of the interfaces. So if you are not aware of the interfaces that it is going to use in an adapter, so then you are not going to assume any of the concept. There may be the class, there may be one adaptee, there may be two adaptee. So you will not have any assumptions within that if you hide the interface details. So in such situation, you can use this adapter as a pluggable, means you can apply where and all you require. So because you will not be knowing, you will not be having any assumption whether it is going to work or not going to work. So there will not be any confusion since you don't know any of the interface designs within the adapter design pattern. So in such situation, I can tell this is a pluggable adapter. So where I can easily incorporate and I can implement this one, so without any assumptions. So that we call it as a pluggable adapter. And the next is using the two-way adapters to provide the transparency. Means adapter design pattern will not provide you the transparency. I told you in the previous example itself. So if it is not giving you any hint on the interface that is being used, so you are not going to assume anything there. So that is means it is not going to provide you the that is a transparency. So you need to provide transparency. So at least provide the two-way adapters. So that is using the two-way adapters to provide the transparency. So if you use the transparency, so that will be helpful. So I can analyze whether I can use this adapter or not. So whether it contains any means more number of adaptee or not. So I can use this adaptee for the next class or what. So these kinds of questions I can look after if you provide the transparency by using the two adapters. That is the same class with the two adapters. So that is that was the another suggestion that is the issue you need to consider. So while providing. And next we will see the implementation details of the adapter design pattern. That is implementation of the adapter design pattern. We have seen the consequences. Next we are going to see the implementation details. Means here I am going to include the implementation steps, how you need to implement, and next we will be having the sample code also. Here implementation means I am not going to give the coding part here, I am going to just tell how you need to implement the steps to be included, and in the next section in a sample code I am going to give the coding part, so where you can implement this adapter design pattern. Now we will see how to go with the implementation steps. Implementing class adapters with C++. One thing you can consider, pluggable adapters. While implementing you need to consider this one. Using abstract operations, delegate objects, parameterized adapters. So here in the implementation section you need to focus on a few of the steps. So that is, so very first one, implementing class adapters using the C++ language, that is higher level language. Java we have used here, so he is suggesting to go with the C++, that is object oriented concept. So we have used Java, so there is no issue. So implementation details, so in the first step he has focused to use the C++, and he has given a hint to use the pluggable adapters. So pluggable adapters are nothing but, so which is not aware of the assumptions that can be arise with the client. So interfaces are not known, so the implementations are not known, so in such a way that that can be used anywhere. So that is known as a pluggable adapters. Okay. So and next is using abstract operations, that also we have done, that is a shape class was an abstract class, right? So you need to use the abstract operations there. So if you use the abstract operations, that is nothing but which contains the definitions only. So that is prototyping. You need to provide the implementation in your classes. So while implementing, use this abstract operations also. And then the delegate objects. So delegate objects are nothing but, so in the delegation concept I have explained. So how we are going to delegate the work from a delegate to a delegatee. Okay, so we use the two objects in a delegation, one object to request the one object to receive the request, another object to process the request. So we use the two objects within the delegation. So that concept is focusing, so he is suggesting to use in the implementation, that is a delegate objects. And then you have got a parameterized adapters. So parameter these adapters can be used, parameter adapters. So So it includes the different kinds of notations. For example, so you can go with this coding part in the parameterized adapters. So you have got that is directory display. Okay, so within that you have got a tree display on tree root, and then get children block. Okay, so you have got a node, get a subdirectories, and you have got a node block. So means it is going to have the parameters. So within the parameters it is going to give me the tree display of the directories, means it is going to display the directories in a tree perspective. So that is why it is taken as a tree display. So which is going to have the information in a left directories, right directories, subdirectories, children, so leaf nodes, like this it will be having. So if you include the parameterized adapters, it will be very easy. And the same way in this delegate objects also you have got a diagram. So that is, you can just go through this diagram. You have got that is a tree display, so which is referred as a client, and within that you have got an operation, that is a set delegate and the display, and then you have got a build tree node. Okay, so then it is going to have the calculation, that is the implementation part, that is the delegate tree. So that is a delegate which is having the implementation to retrieve the children. So it is going to use a get children method. Within that you have got a parameter. So for each child you are going to have a graphic node, means for example it may be the lines, circle, the different kinds of graphical object I told you in the previous example, that can be added. For each node you are going to use this operation, that is a delegate. Using this sample code you are going to build a tree. Okay, so and the same way with the tree display you can just see you have got a delegate arrow mark, so which delegate a tree accessor delegate. Okay, so which is a target, and within that you have got a method, so that is a get children and create graphic nodes. So get children, it is going to display the number of children that is present, and then the create a graphic node, so which is going to first display the contents that is present, and if you want you can just go on adapting the that is graphic nodes to a tree. And then so if you want to browse, means you can use that one, that is a directory browser, so which is connected to a tree display. So there you can see the many of the operations, that is a get children you can have, and create a graphic nodes, you can actually get graphic nodes, and you have a create file and the delete file operations. So you can create and delete the files. So here directory browser is a adapter. Okay, and the tree accessor delegate is a target, so that where I need to do a changes. So I have used the delegate object, that's it. So I explained how to use the abstract design patterns, adapter design pattern. I explained how to use it. So he has suggested how to use this delegate objects in the adapter design pattern. So for that only this diagram, so it is been developed using the delegate object. Okay, so I'll stop here. We'll continue in the next class. Thank you.